welcome to Staad Pro Tutorials. In this session we'll be discussing about the earthquake load analysis. So let us begin the session. Initially start Staad Pro. Select new project. Select space. Give name. Let the units be meter and kilonewton. Select add beam. Initially you need to create a structure. So go to geometry, select run structural wizard, select frame model, bay frame, give length as 15, number of bays will be 5, height as 3 meters, number of bays will be 1, and width as 15, number of bays as 5. Select apply. Transfer this model to main Staad Pro screen. Switch off the grid. Now you need to assign a rectangle property to the structure. So go to General tab, select Property tab, select Define, select Rectangle, give default size whatever it might be as per your requirements. Select the size, select the entire structure, assign it to the entire structure. You can view it in 3D rendering, the 3D structure. Now you need to raise the structure to 10 stories, 5 stories, whatever you require. So select the entire structure, go to geometry, select translational repeat, select number of steps as 10 and default spacing, that is will be 3 meters in y direction. Select OK. Now you can view in 3D rendering the structure. So next step will be turn it to front view, go to support, select create support, pinned, add, select pinned support, select the bottom nodes, assign the support to the bottom nodes. Next, coming to loads and definitions, select loads and definitions. Here we are dealing with earthquake loads, so initially we need to define seismic load. So go to definitions, select seismic definitions, select add. Here you need to select the particular IS code, as for me it is IS 1893-2002. Select generate. So you need to select as per city or zone. Well, we'll be selecting city and the city will be Hyderabad as for me. SMRF will be the special RC movement resisting frame, or you can select ordinary reinforced concrete shear walls as per your requirements. Important building, soil will be soft soil, building will be RC frame building. Generate. Add. Select the factor as 1, add, close. Once the definition is over, you can go to load case details, select add, select the first load as earthquake load in X positive direction, give the loading type as seismic. Next will be earthquake load in X negative direction. Third one will be earthquake load in Z positive direction. Fourth one will be earthquake load in Z negative direction. Fifth one will be dead load, loading type will be dead. Sixth will be live load, loading type will be live. Now you need to select earthquake load X positive direction, select add, go to seismic loads, the direction should be X direction and factor will be 1, select add. Next comes negative direction. Select seismic load. Give the factor as -1 since it is in negative direction. Next, Z positive. Select add. Select seismic load. Direction will be Z direction, factor is 1. Select seismic load, Z direction, give factor as -1 since it is in negative direction. Select dead load. Select add. Give the sulfate. Next comes member load, which is -6 kN per meter, which will be wall load. Next is floor load, which will be -4 kN per meter square, and the range will be 3 meters, so 33 meters up to the end of the 10th story roof. You need to assign this to the entire structure. Later on, coming to wall loads, you need to assign it to beams parallel to X direction and beams parallel to Z direction. After assigning, you can add live load, which will be floor load -2 kN per meter square from 3 to 33 meters. Next comes load combinations. Select load case details, add, select define combinations. First combination will be 1.5 dead load plus live load plus earthquake load in X positive direction. Give the factor as 1.5. Select dead load, live load and X positive direction. Send it to the other side. Select add. Next comes in Z positive direction. Next comes (1.2) dead load, live load minus earthquake load in X negative direction. So select 1.2 as factor and select dead load and earthquake load, send it to the other side. Then select -1.2 and select earthquake load in X negative direction. Select add. The final will be 1.2 dead load plus live load minus earthquake load in in Z negative direction. Select 1.2 and select dead load, live load, send it to the other side. Then select -1.2 and Z negative. Once the combinations are over, you can go to design tab, select concrete, select the particular IS code, which is IS456. Define few parameters like compressive strength of concrete will be 30,000 kN per meter square. Yield strength of steel will be 415,000 for Fe415 steel. Similarly, secondary reinforcement 2. Next, maximum steel ratio will be 3%. Then define commands: design beam, design column, take off. Now we need to assign there is compressive strength of concrete missing. So now select the yield strength of steel and assign it to the entire structure. Similarly, the secondary reinforcement. In the same way, the ratio of reinforcement. Similarly, compressive strength of concrete. Coming to design beam, you need to select beams parallel to X direction and beams parallel to Z direction. Coming to column, you need to select beams parallel to Y direction. So once this is over, you can go to analysis and print, select add, close, run analysis. The analysis might take some time. Once the analysis is done, you can go to post-processing mode. Select displacement for the different load combinations. As you can view it. You can prepare reports. You need to select output and select the reports whatever you require. For example, reactions and maximum moments, shear forces, axial forces. You require only for the load combinations. Select OK. So this generates reports which will be only for 4 load combinations, and you can view everything in here. In order to transfer this to Excel sheet, you can transfer it, the reports, to the Word file and later on to Excel file. In order to transfer to Word file, you need to go to File, select Export Report, select MS Word file. Just need to save the file by giving it name and the place wherever you need to save it. Select Save. Then you come up with this template page. Select OK. Open. So now the printing like starts in Word file to print the reports as it is, and later on this can be transferred to the Excel sheet. You can view the warnings. As for damping ratio should be less than 0.99. We have taken as 5%, so it should be 0.05. Just change it or else leave it. So this is the end of the session. In next session we'll be dealing with a 7-story building. Thank you.